Okay, I guess we'll get going here. Hopefully everybody's in the right session. It's Containers and Cloud Native. It's a technical workshop, part 4 in the series. So today we're going to be covering scale to zero event-driven architecture with serverless. So hope everybody gets what they're looking for out of this seminar. This is a good depiction that we like to throw up. The journey is never easy. And so you can see if you're a fresh startup company, the journey to the cloud, sometimes our cloud native application development is a lot easier because you're not dealing with the legacy software and all the different nuances that goes with that. So that's really what this depicts, that it's a journey, and it involves a lot of people, process. So hopefully you can see kind of where you're at in this journey. And today we hope that it answers some of your questions as you continue on your journey. All right, so what we have today here, we're going to go through a company introduction with who Crossvale is, and then basically we'll introduce the Cloud Native series, go through that. And then basically I'll turn it over to Marcos, who is our Senior App Dev Consultant, and he will walk through the webinar today. And then we'll do a conclusion wrap up, and then we'll close around 1 o'clock. And just to some housekeeping items, everybody is currently muted. The session is being recorded and available after we're done. If you have any questions, you can use the Q&A piece of that to ask any questions. And then use chat for a specific workshop. So you'll get a URL to register for the lab. And I also like to thank Red Hat for the continued partnership with us. And the workshop will remain open for 24 hours after our presentation. Okay. So at Crossvale, we like to focus on 3 main areas that we're seeing as far as emerging technologies and common themes. One of them being automation. We like to help companies where they're taking a repetitive task and try to automate them and drive more efficiencies, and changing the speed at which they can roll out new apps. Also, we're seeing a lot with the hybrid cloud approach, where companies are realizing that not everything can go to a public cloud. And so therefore they need to still have the security of more apps running locally and in the cloud, and needing a way to manage that as well. So we can help you through the process of, determining what apps need to be moved to a public cloud and what apps probably would need to be remain on site. The modern app development, this is what we're going to be working through today, is more or less taking a big waterfall approach and breaking it up into agile microservices, and to move faster and continuous development. So at Crossvale, we're an IT service provider company. We focus on 4 main pillars. We have consulting leadership, day 0, assess and plan. We have our skilled services around day 1, build and deploy. We also, day 2, where we see a lot of customers needing help as well in the managed services. So once you have it up and running, we have a practice around our managed services. And then lastly, we provide subscriptions for our customers as well. Here's a quick snapshot of Crossvale. We were founded in 2001. We started working with the Kubernetes platform in 2017. Over the last 5 years, we've received many container platform awards. We're a Red Hat Apex partner, and you can see some of the other certifications that we have with the various cloud providers. And currently, we have offices in the UK and Spain, and that's where Marcos is presenting today out of Spain, our MIA offices, and then also across North America. How you can engage with us. I mean, we can do discovery calls with your teams. We can do assessments, proof of concepts, statements of work. If you need further information, I have my contact information listed. So we're more than happy to jump on a call with you and walk through those things with you. And hopefully you find this seminar thought-provoking and want to engage with us. All right, so here are the different series. This is the end of the workshops that we've done so far. And again, we do have recording of these ones that we presented in the past. And we are today on the event-driven serverless. We also will do customized workshops. So if there's something that you think would help your team, we will work with Red Hat and your team as well to develop a workshop that we can present and customize it for you as well. Just let us know. And you can always check out crossvale.com events for any future events that we will be hosting. All right, so thanks for joining me today, and Marcos as well. Marcos, like I said, is a senior developer out of our Spain office. And what we're going to cover today are event-driven architecture with serverless. So we're going to go through continuous delivery, debugging applications, application monitoring in Jaeger, application monitoring with Prometheus and Grafana. So those are what we're going to cover today. Everybody is aware of the rapid pace which business is trying to keep pace with other business change. So, and how people are accomplishing this is through continuous development and agile, breaking, like I said, it's breaking down the waterfall monolithic applications and breaking them into tiny microservices and being able to deploy them quicker. And in the whole practice of things, the container platform has made this a reality, and also packaging in the security piece of it as well. So the path to cloud native applications is it's not going to happen overnight. It's a process. It starts with people and not just a product. So as you can see, it kind of goes through this evolution until you get down to the microservices path. As you reorg to DevOps, you do self-service on-demand infra, you do some automation, continuous delivery, advanced development techniques, leading into microservices from a monolithic approach. All right, with enablement is the key. Red Hat ensures that you have the best of breed practice. They have automated Kubernetes application with DevOps in mind. They also have the middleware stack, which is a cloud native middleware application services and service mesh. And then code ready. Code ready is important so that all your developers are in sync in programming, developing off of the same code. And it helps speed up development quickly. Okay, so our intention today is not to provide a one-on-one of OpenShift. We do just want to pick a few topics, and today we're going to automate applications through operations and DevOps in mind. Let's see here. Here. All right. OpenShift is far more than a platform on which containers reside. In fact, the word platform simply does not do justice. It's more like an automated ecosystem that accelerates application productivity anywhere. It's lifecycle management from code to review across data and services. So as you can see through this diagram, it touches all these different facets of code development, with Red Hat OpenShift being the base of it, as it goes through build, test, deploy, monitor, review, and to code. So building the next generation applications. Change means doing things differently. Yes, lift and shift might be necessary. However, refactoring Java monoliths into microservices offers huge advantages, and OpenShift provides the tools to ensure its fast and secure delivery. It's very easy to move these technologies, but not actually change the way in which you build and deploy application. Agile is all about small incremental change rather than the big bang. The key to this is the container. The reality is doing containers en masse, it's actually quite difficult, even complex. So doing containers at scale is hard. This is why the platform matters. But hey, that's the concern of ops, and why all you care about is what can I put in the container and how much effort can be reduced here. Again, this is where OpenShift steps up, ensuring every container has what you need, and more importantly, the right amount of it.
So what are we going to work today in terms of add-ons is that we are going to start with a simple microservice architecture of a store. And then we are going to use, first of all, the Red Hat OpenShift streams, which is a scalable, distributed, and high performance data stream service. And then we are also going to use the JFrog Data Grid product. All of this deployed in OpenShift. The MQ streams in order to send events to the listeners, the JFrog Data Grid in order to work as a cache for one of our services. And we are going to finally use OpenShift Serverless and Knative in order to allow the scalability of the services to zero. So normally when you have, in this case, a Kafka topic, you have an application. So at the end of the day, in this terms, a container that is listening from events in a Kafka topic. By the use of the serverless function, what you can do is scale that application to zero if there is no messages in the topic, because we don't have an application, we don't want an application running and consuming resources if there is no messages in the topic. But at the same time, we want that if a message is received, the application can be started automatically, consume the message, and process process the message properly. So in the next slide, this is the architecture in which we are going to start. This particular architecture shows the technologies that we are going to use. So there is one service which is written in a Spring Boot. There is 3 of them that are written in Quarkus. And we have 2 of them with a Postgres database, one of them with a Mongodb, and the other one who is the card shopping service that instead of having a database has a JFrog Data Grid service in terms of provide a high performance service. We are going to start creating this scenario in an OpenShift namespace, deploying the databases, deploying the application, making some code changes. And after that, we are going to install the Red Hat OpenShift streams to connect the card service with the order service. And we are going to include a payment service, which is going to simulate a payment. So the idea is that you have a shopping cart, then you make the order to buy those products. And the order sends an event to the payment service in order to process the payment, which communicates back to the order service to update the order status, which is saved in a Mongodb. And finally, we are going to include the payment service as a key native service, which will allow us to have the payment service stopped and only started with if there is any message that was sent by the order service. So the card shopping service and order service are communicated via the event of creation of an order, and the order also process payments via also a Kafka topic. But the difference is that the application that is listening this Kafka topic is going to be scaled down to 0. This is when it comes one of the benefits, in my opinion, of Quarkus, which is the very slow startup time of the Quarkus applications. When you have this kind of applications that are scaled down to 0 elements, it allows you with a very low response time to start your application and start listening to messages, even if some moments ago it was stopped. And finally, if we have time, we're going to show you as well some capabilities of the OpenShift finance, which is based on the Tekton tool. So we are going to deploy an application and try to show you how the Tekton pipelines and the Tekton tasks are executed in an OpenShift cluster. So first of all, you would need to register in the workshop, which I have the URL here. So the moment I'm going to send the URL in the chat. So this is the URL in which you can register yourself. The moment you register, you are going to be assigned a user number. So mine is user 1 because I am already registered, and you will have automatically access to the OpenShift environment and also to the code-ready workspace. So I'm going to share my screen, and I am going also to send the code-ready URL. So the moment you register, you should be able to log in into this URL, which it will give something to you, something like the screen I am seeing at the moment. So mind that the password, I'm going to write that also in the chat, is Red Hat 1 exclamation sign. So I'm going to log in. Everyone has the same password, so be careful. Okay, so I am already logged in into the code-ready workspaces. And in order to start the workspace itself, you need to click in the workspace name, user 1 workspace, and it will start the IDE, which is basically an IDE that is code-based. And okay, so in here we have all the tools that we are going to need in order to complete the workshop, but we have one tool missing, which is the Git repository, which I'm going to paste the URL also. In the Git repo that I am pasting in the chat, wait, I think I sent it. That's correct. In that Git repo, we have the code of the services that we are going to use today. We have a lot of resources, a lot of code with, if it is not fully coded, we will need to make some small modifications in order to not to start from scratch. So first of all, I will need to clone the repo. So I can click the clone repository here, and I can paste the URL and click enter. So as you can see here on the left menu, I have downloaded the repository, and I have the payment service, the order service, the inventory service, the UI, which is because this store has a web interface in which we can see the products and its price and everything, and also the shopping cart service. So what we're going to do first is that we are going to start deploying the services into the OpenShift cluster. So we will need to try to access the OpenShift cluster, which it is. A moment. The URL, I have it somewhere. Okay, so this is the URL of the OpenShift cluster. I'm going to paste that on the chat as well. And we need to do login the same way that we did on the Code-ready workspace. Okay, so I have multiple namespaces. For now, we're going to use only the namespace, which is your user ID and then Cloud Native Apps. This is the one in which we are going to deploy all our services and applications. So we are going to start with the inventory service. So in order to connect the Code-ready workspace to the OpenShift, we need to go to the menu in the right, which has 3 buttons. One of them is a little cube that we can click, and we have multiple options here. One of them is login to OpenShift and new terminal. Those two are the ones that we are going to use the most. So if I double click login to OpenShift, it will log to the OpenShift with my user that I have already used to log to the Code-ready workspace. So if I open a terminal now, and I try to do OpenShift commands like OC project, I can see the same, or OC get projects. I can see the same elements that I would see on the web console. Since we are going to work on the Cloud Native Apps, I'm going to change the project to Cloud Native Apps. So everything that I do is going to be isolated into my Cloud Native Apps namespace because I am working with the user one. So if you would be able to join and try to follow the workshop with me, you will have your own namespace. And this workshop laboratory will be running for 24 hours more. So even if something is missing or you want to test some little changes, or you want to do some small debugging or validation of how these tools work, it is something very, very easy for you because this environment will be running for 24 hours more. So first of all, the inventory service, if I recall, it is a Quarkus application. So in order to deploy the application, we will need to add some extensions that are missing. If you recall correctly, I said that there were 2 services that have Postgres database. One of them is the inventory service. And at the moment, it doesn't have any integration with the Postgres database. It has the properties here, but there is a library missing. And the library is the JDBC Postgres extension of Quarkus extension. So first of all, we will need to add that dependency to the Quarkus application, because at the moment this application is functional locally, because it has a profile, which is a dev profile that works with an H2 in memory database. We have worked with this application in the past, but if we want to deploy this application to prod, so to a production namespace, which is not a local, let's say like in OpenShift, we will need to add the Postgres driver and the Postgres, all the required extensions in order to be able to connect. So to add a Quarkus extension, you can do it manually, but what I do is that I go into the Maven project, and then I execute a Maven command, which is Maven Quarkus : add extension. And then we have to specify the extensions, which are JDBC Postgres SQL. So if I execute this, it should show a message that the extension is added to the extension has been installed. So basically what this means is that we have a new dependency in our POM, which would be the Postgres extension, that it should be here. So this is basically what the Quarkus add extension does. It adds a dependency to your application. So you are able to connect to the databases that you're going to use. One thing to consider is that we have the library already, that the extension was missing on the given code, but we have a problem is that we need to deploy the database in OpenShift in order to be able to connect to it. So what we're going to do is that in the namespace, we can go to the Topology View, and we will see that there is nothing basically. So we will try to add a database. We try to find Postgres, and we will start with the Postgres ephemeral, and we will click instantiate template. Basically what we are going to write here, the details of the database name or the database host and everything is going to be the same that we have on the application. So when the inventory application starts, it's able to connect to this database. So the service name is going to be inventory database. The username is going to be inventory. And the password is going to be, I think, my secret password. Yeah. I'm going to copy and paste here. And the database name is going to be So these properties that I am writing here are basically the same as here. So the moment I click create, a new Postgres database will be created. It will start a deployment. It will take a few moments to start, but as you can see, it is starting. So now what we need is that we need to deploy the inventory service. So in order to do that, I need to open a terminal again. I need to go to the inventory service. So one of the extensions that the inventory service has is the OpenShift extension. So if I do a mapping link into the Maven clean package and skipping the tests. Then the Maven configuration of the application is capable of connecting to the underlying OpenShift client and do the deployment for you. I'm going to skip the test. We will see it on the Maven output when it starts. So now it is doing you can see there are some OpenShift image OpenShift deployment OpenShift processor. So the Maven command is able to connect to your underlying OC client and start doing everything that it needs to do. So it will compile the application, it will build the image for you, and it will also deploy the image for you. So when you have some local environment like we are having at the moment, we have the code ready that has access to the OpenShift clusters in which we want to deploy. It is very developer friendly because it saves you a lot of time, and it also is running and it's being configured in a very similar way that it would be in production. So in a more productive environment, we will have normally a continuous integration pipeline that builds the image for us. But we are going with the Maven approach for the moment, and we have time at the end, as I said, we will write a Tecton pipeline in order to configure the deployed application in a more continuous integration manner. So now we have the inventory here, so if I want to do an unsecret pods, I can see that it is already running. There is an inventory pod, a build pod, which was responsible for the building of the image, and also the database pods. So one thing to consider is this really working? So if I click here, I have the application running. So we have some inventory here populated already in the database, but you can see that the Quarkus extension, the OpenShift extension, has already added an external route for us, even if, as you recall, we are going to access the inventory service with a web UI. So we wouldn't be strictly the necessity of creating a route, because this application is not really required to have a access outside the cluster, because normally you will go through the web UI. So one thing is that this topology seems very easy, seems very good, but it has one problem. And the problem is that when you have multiple applications in a namespace, sometimes it becomes very difficult to distinguish which application is connected or communicating with which application, etc. So what we are going to do is that I am going to send you some commands on the chat, which are basically labels and annotations that when really doesn't need to have too much effect on the application itself, but we can see now that the way that OpenShift console displays the topology view is different. So now this is a group of applications that is called inventory, and we know that the inventory Quarkus application is consuming the inventory database, which is a Postgres database. So today we will see that when this view becomes a little bit complex, because we will have 4 microservices with database, no, 3 with database, 1 with a JBoss database service, and the other one which is going to be the Knative service. It really becomes very difficult to try to identify which application is communicated with which application. So yeah, we already have the the inventory service. So we are going to continue with another service. Maybe let me close this window here. Okay. So maybe the catalog service. So the catalog, I think, is the Spring Boot. Yeah, as we can see, it has some dependencies for Spring Framework. Mind that the parent is not the normal parent, is the Red Hat version of the Spring Boot of the Spring Boot parent. And if you recall from previous workshops, the catalog service is going to communicate with the inventory service. So that should be done in a service, which is in the client. Yeah, inventory client. So the catalog service is going to use the inventory client in order to communicate with the inventory service. So we want to open a new terminal. Let's see. So I need to refresh So I'm going to refresh the code ready because something is broken. So when this is refreshing, we are going to deploy the catalog database. So we are going to do basically the same as an inventory. Where do we have the database? And in this case, it's already, this one, not ephemeral one. We're going to start here the template, and the service name is going to be catalog because it's going to be the catalog database. Username is going to be catalog, and the password is going to be as well. My secret password. The database name as well is catalog name. Okay. So this already started. Yeah. I'm going to go to catalog. Okay, so first of all, we will need to build a Spring Boot fat jar that has all the dependencies, and with that jar file is the one that we are going to use as input of the image build that we are going to use. So first of all, we are going to need the Spring Boot jar. So in order to do that in the catalog service, we need to execute the maven clean package command, following by the Spring Boot repackage goal, and we are going to skip the tests as well. Okay, so we already have the catalog database ready. It will take some time because it has to download all the dependencies. Okay. It is ready. So do we have, since that we have a Spring Boot jar file here. So what we need to do today is, or right now, is to start creating a new build. So in order to build the image, one option that OpenShift has is a binary build. So instead of having a Docker file or something like that, it makes the build process easier because you can create a build configuration, which is an OpenShift object of type binary, and that enables you to specify the base image, which in this case is going to be an OpenJDK image. And with that and an binary input, so the jar file we just built, it is possible to create images. So in order to create the build, we need to use the OC command, OC new build, and then we need to specify the base image, which is going to be registry.access.ubi8/openjdk-11. Now we need to specify the type, which is binary, the name, which is going to be catalog, because we are building the catalog application, and we are going also to add a label, which is app equals catalog. So I think everything is okay. Yeah, so if okay, as you can see, the inventory build configuration was not created by us, it was created by the Quarkus extension, and it's of type Dockerfile, while the catalog build configuration is of type binary, which means that we will need to provide the input. Let's see, instead of allowing Maven to compile and do everything, we need some manual steps in this case. So we have already the build, and we have also the we have also the jar file. So what we need to do is to start a build from the jar file that we just created with the Maven Spring Boot prepackaged O. In order to start the build, we need to execute the start build command, and then the name of the build, which is catalog, and then specify for which file we want to, which file is the input of the binary build. And that is target, because I am on the catalog product service, and then the jar file that is the outcome of the Maven build. And if I add the follow flag, it will show us the log of the binary build. So one thing to consider is that this particular command is not going to deploy anything. It is going only to create a new image that we can use in our deployments. But it will not deploy anything for us, because its purpose is only to build a new image, and then we will deploy the application manually something similar as we did with the build, we are going to do with the deployment. Okay, so the push is successful. So as you can see here, this is the image that we just built, and it's referencing to the internal OpenShift image registry. So now it is necessary to deploy the application. So one easy way to do it is to use the new app command, the OC new app command. Then we need to specify the name catalog, and we need to specify that is as deployment config, because it's what we need to specify. And we will need, since this is a Spring Boot application, we need to specify in an environmental variable the Spring profile that is going to use. So we can add the environment, that minus E that I write is minus environment, and we are going to add the Java options append property, and we are going to include spring.profiles.active equals OpenShift. Okay, and then we click enter. So what has been created here? A deployment of the catalog. One difference is that this kind of deployment is not exposed automatically. So there is no no URL to connect to from outside the cluster, although from within the cluster it can be reachable. It is not reachable from outside the cluster. In order to expose the catalog service, we need to first identify the name of the service that is bound to the catalog application. So we can do an OC SBC, and we can see that it is the catalog one. So the command OC expose service catalog is going to expose this service, which is the object that is used to basically resolve the pod IPs of the catalog application deployment within the cluster. If we are exposing it outside the cluster, it will create a route that will enable us to connect to the catalog application pods from within outside. So yeah, it is already, as you can see, exposed. So if I do OC get routes, I can see a route here. So if I copy this, I try to access over the internet, application is not available. Why not? Maybe because it should be HTTP. Yeah. So it should be HTTP because we have not specified that the route is secure. But it is possible to have an insecure application, so an HTTP application, and enable the route to be to add a TLS termination only to the outside caller. But in this case, we have not specified any of that. The application is exposed as HTTP. So as you can see, it is something similar to the inventory application happened, and that is that the applications are not really grouped. It is not possible to see the link between one another. So we are going to type the message of the labels in the chat. But basically it's the same concept. We are adding annotations, we are adding labels to the catalog and to the catalog database deployments in order for us to have a simpler way of seeing the applications in the topology view. Okay, so now we can see that the catalog application is connecting to the inventory application. And one thing that we need to do now is that we need to start with the shopping cart service. If you remember, the shopping cart service, that is the service that connects to the JBoss data grid component, but we do not have a JBoss data grid component yet. So we will need to deploy it. So we will first deploy the JBoss data grid, and then we will go to the cart service, and we will do the changes that we need to do in order to deploy and connect to the data grid. So in order to deploy the data grid, which is an application that runs in OpenShift, we need to use as well the OC new app command and specify that it will be deployed as a deployment config. And then we need to specify the image, which is going to be span/server 12.0.20 final -1. And then we need to specify a name, which is data service. Some environmental variables like the user and password that we're going to use to connect. So we will check that everything is okay. I think everything is okay. So I click on okay. Okay, it is starting to create data grid service. So while the data grid service is starting, let me go to the cart service and we're going to check what we have here. Okay. Okay. Okay, so we already have in the application the infinite span annotations included. So we will need to create some resources, but as you can see, there are a lot of configuration already done. One configuration that we need to include is the the context initializer that we need to use to to connect to the JBoss data grid. So we will need to create basically a serialization context initializer in order to be able to store these objects in the the instances of this particular Java classes into the data grid service. So I'm going to create a new Java class, and I'm going to name it context initializer.java. Native. Not more, right? Yeah. Okay. So what do we know? What do we need here? So first of all, this is an interface which is called car context initializer that extends the serialization context initializer of SpinSpan, and the interface is empty. So now what we need to add is the annotations. The annotation to auto promo schema builder of infinite span that is going to be able to serialize the included classes, and the classes that we need to include the classes, and this is going to be a list of classes, and basically we are going to include all the classes that we have on the model. So any object on the shopping cart in the model, any object that the shopping cart basically handles and uses, is going to be possible to be stored in the data grid. So we are going to start with shopping cart.class shopping cart item as well. Dot the promotion and the product. Okay. And I'm going to specify the package name, which by default is empty. I'm going to specify that it's cool store because we are building the QStore application. And now we need some things. We need to modify the code in order to be able that the cache integration with the JBoss data service is really done. So in the service implementation, in the shopping cart service, we can see that there is already some code here. There is not much that is needed to be coded, but one thing to do is that we need to inject the remote cache, which is an infinite span object. So in order to do that, we need to with the get annotation, and to use the remote, and specify the cache to use, which is the remote card cache, and then specify the type, which is each string, and the type of the object is going to be a shopping cart. Okay, so we have, if you mind, this was failing before because the object to communicate with the JBoss data grid was not created. Now that we have the cards created, it is possible of the code that we already had provided in the repository, possible to put and to identify to put by ID and to get, and basically to create read, update, and delete operations into the JBoss data grid application. So one thing to need to modify as well in the card shopping service is that we need to, we are going to include a service that is going to return the cards that we have in the cache, in the JBoss data grid store. So in this particular component or in this particular service, it exposes an HTTP API, which is the card resource here, or well, it is defined in this or implemented in the card resource, that we will need to add some, there are some comments here of Kafka and everything, but we need to add one method first, which is the getCard method. And the getCard method is going to communicate basically with the shopping cart service implementation, and the method is the method getShoppingCart. Okay, so this particular method, which goes by cart ID, is going to be integrated with the JBoss data grid that we just deployed. So first of all, we need the annotations. So we need to do a get, because we are getting shopping cart, and we need to specify the path as well, which is going to be cart ID. I'm going to copy this here. And then we need to write the method that is going to return a shopping cart. Get and it receives a string which is cart ID. That's failing because it is not. So we call the shopping cart service and we are the card by cart ID. Okay, so this particular service has already some other annotations here, which are things that we are going to uncomment the moment we start the Kafka integration, because the card service is producing messages to the order service, basically. Okay, I think this is ready. Just going to check if I do any clean package. Okay, so I just did a clean package, but if you check, there is no card service deployed. And there is no card service deployed because there is no Quarkus extension added. So I need to add the extension called OpenShift. So if I did it well and I do the same command as before, this will hopefully okay, it will deploy it. No, why it's not deployed? So if it's not deployed, then it should be because the OpenShift extension is not configured. So we will need to go to the application properties. Yeah, we need to add the configuration of the OpenShift extension. So we will need to add some properties here. Properties that we need to add is Quarkus.kubernetes-client and then trash search. This is important. It's going to be true because the search that we are using are not really valid, or what are some of them are self-signed. And then we need to specify we want to deploy the application. It's true. And we need to specify also the deployment target. Which is OpenShift. The build strategy. Now OpenShift. Build strategy. Docker. And finally, if we want to create or not a route. So if we want to expose or not to expose this route when created. Okay, so I think that now it is okay. Let's try. Let's try to see. Okay, now it is working. So yeah, normally if the extension is not configured properly, it will not work. So now we are basically doing the same, or well, deploying and building the application image the same way that we did with the agriculture inventory. I think it was the inventory application, the other Quarkus application. And let's see. We can see the data grid service already running. Now it's building the image. Okay, so pushing the image to the image registry. So in a few moments you could be finished. Yeah, there you go. We have the card application here. And as always, we need to add some labels. I'm going to paste it on the chat. And I'm going to apply the labels. Okay. So now we have the card service, the data grid service, and all the integrations that we have with the applications that we are using. So yeah, there is a Quarkus homepage application here. So the application is really up and running. Mind that if this circle that is around the application is dark blue, it means that the application is running and it is serving traffic and everything. If it is light blue, it's that it is in the process of starting, and when it becomes dark blue, it's when the application is already started. So we have one service left that we need to deploy, and it is the the order service. So let's go to the order service. Let's close this. Okay. So the first thing I'm going to do, if you recall, the order service was connected to a Mongo database. So we need to to add that extension and to add all the extensions that we may need. And in this particular case, we will need some extensions. We are going to need some REST-EC reactive Jackson dependency, and also Mongodb Panache. Let's see. So the Panache is like an object relational mapping framework, like Hibernate, but built for Quarkus, which allows you to connect to the database. So if we go to the order service and try to check the code, what do we have here? So we have an order resource in which we need to add the annotations here. The annotations, sorry, the methods that we need to. So the service is not coded, okay? And if we go to the entity, yeah, it is the Panache entity, it is ready. So the only thing we need to do is, well, do the operations that we need to include into the order resource to connect to the Mongo database. So to either read or update or create objects in the Mongo database. So first of all, I'm going to specify the path that is going to be API orders. And then we need to add add and update the status here. So the objects that we are going to, or the objects, the methods, first of all, the one that I'm going to include is the list. So let me check. And I'm going to return a list of order, which is basically the entity that we have configured to the order service. Then we're going to return order list. Yeah. So this is the only thing that we need to, well, to list all the objects that we have on the database. So we also need to do a post, which is going to be the add method. But we are going to return a list of orders, and we are going to add an order. So basically, what we are going to return is all the orders, but we are going to save this particular object first. So persist and then do a list all in order to return all the elements of the database. Finally, we are going to do the update status method. So this is really well, it is a get, it returns an order, but it tries to get the status of the order, updates its status, and then persist the object on the database. So it is going to be a get, it will not have a body on the request, but in the request of the path, we are going to specify the order ID and as well the status of the order. And we are going to return the order that is updated is going to be an update status method call, and it will have order ID and status. So yeah, first because so basically what we need to do first is to find the order by ID. So we use the find by order ID method of the Panache entity, and then we can say that the new order status is whatever we have on the status field, and then we update the order and reload the order. Okay, so this particular service is not really complicated at the moment, because it will basically read or update the status of an order in a database, in a Mongo database. So one thing that we will need to configure as well is the Mongodb configuration. So we need to add the properties of the Quarkus.mongo what do we need to add? Connection string, which is going to be, have we deployed a Mongo database? I don't think so. No. Okay. So one thing to need to do is to deploy the MongoDB. I completely forgot about that. So going to open a terminal. Going to check that I am on the cloud native as namespace. So we need to deploy the MongoDB. So in a similar way that we have done before, we are going to do OC new app command, and we are going to specify that this as deployment config, and that we need to specify the Docker image, which is Mongo 4.0, and that the name is going to be what database. Okay, so it should be, it is creating. Okay, so we have created a database which is called order database. So what we need to do is to connect to the MongoDB, which is called order database, on the default form, which is 27017, and then we need to specify also the MongoDB database, which is going to be the order database. So we need to be sure. Oh, okay, the order data is already deployed, and then since this is a Quarkus application, the order service, so it will be relatively easy to deploy, because the only thing we need to do is to do a clean package and skip the tests, because the deployment configuration is already, so the OpenShift extension, so the configuration of the deployment via the OpenShift extension is already done in the provided repository. So we will need to do the label. We just need to pass the chat as well. So we need to, in a similar way that we did with the other services, we are going to label the order services, the order service. It is building the application. Okay, it is building the image already. So while this is being built, mind that normally if you are going to do this particular scenario in a product environment, I will not do it with the Quarkus extension. I will do it in a more standardized manner, but this is very useful for local development. So I am going to apply the labels. Okay. So now, yeah, should have some labels here. Okay. So mind that we already have 8 applications deployed, 4 databases, well, 3 databases, and 1 data grid service, and 4 microservices that are integrated among each other and among these databases. If we don't have this kind of labels, it really becomes a little bit difficult if you don't know all the applications, how the applications are being connected with each other. So I'm going to check if the order service is working, and I need to check the orders. Something is not okay. Something is not okay. I need to double check that. What? So we have the orders here. API. Okay, something is not correct. Just going to check the log. So we go to the pod, go to the log, try to see what is telling us. Okay. Seems to be okay. I'm going to do it from localhost. So right now I'm connecting to the pod itself, so I will not need HTTPS. But yeah, this is okay. This is so what is happening basically is that for some reason, so I'm going to do, I think it is, it's not working. Right. So something is wrong with the route because the application is working. So what is wrong with the route? Let's check. It is forwarding to the Is that not HTTPS? Yeah. So it's HTTP. Yeah. That was the reason because from the pod was working on. I thought that the route was SSL, but there is no. It is not configured. So my bad. Okay. Finally, we have all the applications deployed, but we have some service missing or some application, which is the UI, which is the service that is called Cool Store UI, that we will need to deploy. So in order to do that, this is a JavaScript application. We will not need to a lot, but we will need to use some npm commands. So we are going to use the npm command node shift. So the moment we are able to deploy the application, we can do a npm run OpenShift or npm run node shift, and that will deploy the application for us. Okay, there are some warnings that we can ignore because we are not in a production environment. Okay, so I did an npm run node shift, which is an utility that allows to something similar to the Quarkus extension that is going to create the resources that we need in OpenShift. So hopefully soon in the topology view, at the moment is still building the image, but in the topology view we will be able to see an application running. So let's see. It is okay. Okay. Now it's pushing the image to the registry. So this build is not really done locally, it is done on OpenShift. In a build configuration in OpenShift. So we do not need to have the software installed, because OpenShift is capable for us for doing this kind of let's see, configurations for us. Well, not configuration, but one of the things is that if you do a build, normally you want to build a Docker image locally, you will need to have, well, the Docker daemon, everything configured in your laptop. But if you have this kind of OpenShift source to image build, that is what we just built, this, or a binary build, or a Docker build, it really allows you to this kind of flexibility that sometimes is, well, sometimes locally it makes your life as a developer a little bit harder. So one thing to consider is that the UI is not exposed. So I will need to expose the service of the cool store application. And as always, I will apply the labels and the annotations. So in the topology view, we can see something a little bit more, well, organized a little bit. Okay, so this is what we have at the moment. If I click here, we should see a JavaScript application that is obtaining all this data from either the catalog, the inventory, or the shopping cart service, or the order service. So everything is integrated among each other. So this is what we have for the moment. We have not started with AMQ stream or any event-driven services, because first of all we need to deploy all the architecture and try to configure everything that we needed in order to be able to execute the application. So now that what we are going to do are basically three things. We are going to deploy Red Hat AMQ streams, which is basically Apache Kafka. And we are going to connect the shopping cart service to the order service through one Kafka topic, which is going to be the order topic or orders topic. And at the same time, we're going to connect the order service with the payment service. I don't have the PowerPoint with me, but basically when you have your shopping cart in the web store application and we click buy or check out, it will send an event to the order service that will connect to the payment service. So what do we need to do first? So to do first, we will need to to deploy the Kafka cluster. Mind that in the scenario that we are following, the Kafka or the enqueue streams operator, it is already there. It is already installed. So it is not necessary to install the operator, but we need to create the Kafka cluster. So in order to create the Kafka cluster, in the developer view, click the add button, and we need to search in the catalog. And what we need to search basically is Kafka, which is a Kafka cluster, basically. And we are going to leave all the values as they are. So by default, we are not going to complicate the things more. Okay, so while the Kafka cluster is being deployed over here, what we are going to do as well is we need to create topics. We need to create two topics, the orders and the payments topic. And in order to do that, we need to do to add a Kafka results. Okay, let's go to the catalog. Try to find it here. Why there is no Kafka topic? Okay, something is not okay. Okay, Kafka space topic. Okay, so first of all, topic name, orders, and then we can click on create. We are not going to create any special configuration of this topic, and we need to create another topic, which is going to be the payments. So allow me to move this somewhere. I don't know why it's getting that big. Okay. Okay, so we have the Kafka cluster over here and the services down here, which are not yet connected to the topics. So they are at the moment, everything that is connected in the applications are through I would say HTTP. So first of all, we're going to start with the integration of the application with the Kafka or enqueue streams integration. So we need to go to the payment service. And payment service is the service that we have not deployed yet. And one thing that we need to add is it is a Quarkus framework, so it is a Quarkus application. So we will need to add the extension. Sorry, I typed it wrong. Quarkus add extension minus the extensions messaging -k and that will add the that will add the libraries that we need to work with the Kafka topics. So in the payment service, now we need to modify the code in order to, well, actually there is nothing in the code. So we will need to add some configuration to, well, to connect to the Kafka cluster. First of all, I am going to add some properties. That I am going to bound to some fields in the class. So I'm going to say that we are going to have a config property that I'm going to, well, first of all, I'm going to write all the properties. The properties that we need, basically, we want to Kafka are the bootstrap servers. We will need as well the payments topic. We will need, we will need as well a serializer for the topic value, and also these are properties. This is some mapping that I am doing to some fields in the class, but this is actually serializer. Okay. And then I'm going to need to bind these fields by using the annotation config property. Let's see if it loads to a particular name of the property. I'm going to name it enqueue messaging. I think it's okay. Going payments bootstrap.service. Is it okay or is it not okay? Oh, was this maybe cannot be an array? Yeah, it is okay. So I'm going to copy this property. I'm going to paste it everywhere, and then I'm going to rename. So payments topics is going to be payments. Oh, this is not. This is servers. Payments topic. The topic value serializer. We are going to name it value serializer. And then we need to move on this, and this is going to be key serializer. Okay, so this is a binding that I am doing of application properties to these particular singleton fields. But we will need more objects. First of all, we are going to have a producer. So something that is going to send messages to the payments topic. And basically, it's going to be like that. We are not going to initialize the producer. And I am going to add, maybe, because it could be that we need a logger. So this is going to be normal simple logger password for Java logger. Not a lot of complication here. Okay. So now, oops, sorry. As you can see, there are some methods that we need to include. The first that I am going to do is that I am going to include the pass and fail methods here, which are methods that are going to really send the notification either of success or failure or failure to the topic. So going to be private and void, and it's going to be named pass because this is the source method, and we're going to need an order, payment ID, and also maybe some remarks, and the same with the fail method here. So it's going to be named fail. So in these methods, we are going to include the build of the event. So it's going to be a JSON that we are going to send to the payments topic. Now, one thing that we need to include is in order to receive the event, we are going to do a post. So basically an HTTP that is going to be named handle cloud event, named here. And we are going to receive a string, which is our cloud event JSON. So we are going to receive a JSON over HTTP, and we will evaluate if that payment is going to be successful or not, and that is where we are going to send the notification back. So we are going to, first of all, I'm going to build a JSON object. I'm going to name it event out of the cloud event. Why is this not? Cloud event JSON. Okay. I'm going to create as well a payment ID that we are going to calculate as I think it has to be a integer, and it has to be a number. So we will need to calculate that by doing some kind of random operation that we are going to. Why is that? I think it's okay. Maybe column. I'm going to multiply that by 100,000. Okay, so this is the payment ID that we are going to use. I'm going to say that for the moment, the order ID is going to be. Okay, so what are we going to do with this event? First of all, getting the order ID. It's going to be that order ID. So we expect this JSON to have a root element which is named order ID, and that is what we are going to receive. What else? We are going to receive the total number of elements in the order. So it's going to be a total, and then yeah, we are going to need to receive the credit card details. That is going to be as well, sorry, another JSON object that we are going to get from the key credit card. So we expect this JSON to have an order, a total, and a credit card. And also maybe a name. And get string name. Okay, so this is all that we need to receive. Now we are going to process the payment because we have the credit card details, we have the name, we have the order ID, we have the total of the order. So since we are not going to process the payment, I'm going to thread of the sleep. that probably I will put everything in a try catch. A thread.sleep 5 seconds only to simulate an external call to processing service or something like that. So I'm going to catch all the exceptions, and I'm going to choose the logger for that. And we are going to say failure. But when we fail, we need to really use the fail method. So the order actually is the order ID. Payment ID, as a remark, we are going to include something like the payment of total. I cannot use total because it is not failed. And we are going to include also the message that we have in the section, for example. So if it fails, we will have the order ID, the payment ID, and the message of the failure. But if it not fails, we want to pass. So we need to send the order ID, the payment ID, and we need to payment for a total of, and then I use total. Okay. Is complete. Okay. So if the processing of the payment doesn't fail, then payment is successful for us. Now the payment and the passed or failed payment method are methods that are going to communicate with the Kafka topic, and in order to do that, we are going to create a JSON object that we are going to call payload, because it's going to be the payload of the event. Going to be a new JSON object, and then we need to add some elements here. So we will need to put the order ID, something that we need. We will need to put as well the payment ID, the marks, and we are going to include a new field which is going to be status. So the value of a status, since it is completed, is going to be hard-coded to completed. And the rest of the values of the JSON, we are going to map it to whatever is on the incoming variables of the method. And this is order. So I'm going to write a log here. And then we need to send the event to the Kafka topic, to the Kafka payments topic. So that is why we have a producer injected, and that we are going to send producer record, of type string. Basically the payload is the payload, and the topic is the payments topic. We call it. Yeah. So we said that it was a producer of a string. So this producer is going to send the event to the payments topic. We are going to do the same for the failure method here, but this is failure or failed. Payment failed. Maybe a warning because we have already logged the well, the error with the exception and everything. Okay, so another thing to consider is that we need to include some a method basically to receive events from Kafka as well, because the method that we have already configured is to receive events on the JSON on an HTTP and handle it over to a payments topic. But we want also to be able to receive the same event through Kafka. So what I'm going to do is that I'm going to say that we have a incoming here, which is the orders topic. And then we are going to include a method that is a completion stage void. And this is basically how I need to receive the event from the Kafka topic. So it is going to be a record type string and message. Okay. So we'll put info message received from Kafka. I'm going to do this. So basically what we are going to do is that we are not going to overcomplicate things, and we are going to call the method that we just write for being processed over HTTP to whatever is on the payload of the message. So we expect exactly the same message either through a Kafka topic or through an HTTP endpoint. And then we are going to return that have acknowledged the message. Now, we have not configured yet the Kafka producer. So we need to configure. So we need to add an init method that is going to be basically a method that is called init, and it's going to have an observation annotation on the startup event. So anytime the Quarkus context is started, this method would be called. So before the application is serving HTTP request or it is consuming messages from Kafka. So it is possible to initialize a properties object that is going to have the connection details to Kafka. So I'm going to call it props, and I'm going to say that the producer, that is string, is going to be Kafka producer. Okay. Now the props that we need to, the properties that we need to include are basically 3 bootstrap.servers, and then we need to add 2 more, which are the value serializers and as well the topic serializer and its values, not topic. And the values are basically the ones that we have already included as fields of the application. This is payments topic. Oh, it was called. Oh, sorry, just server. Okay, so these are all the properties that we need. Yeah. So now we need to include the messaging configuration. So we have only included placeholders for the properties, but we need to include some properties in order to configure the either all the outgoing messages to Kafka or incoming messages. So I'm going to paste all these properties because if not, it's not going to be possible to find it working. So basically the configuration of the outgoing stream. So the Kafka producer that we just used. You have here the serializer, the connection to the Kafka cluster, which is how we name it within my cluster. And basically something similar, but to the incoming service that we have also configured in the payments application. So now one thing to consider is that if we right now try to execute this application, we should be able to deploy it. So we have the so we have the OpenShift extension already configured. Okay, I'm going to build the application. It will take some time. This way of building the application, we are building basically Quarkus application, but at the moment we are using a Docker file to to connect to the to connect to build the image. But I was just noticed that these properties could be that is not properly. No results. Oh, yeah, I did something wrong. It is not going to work. Okay, so basically this should be there. Why is it not there? We're going to if it fails, but what happened? Okay, try again. Okay, so what is happening with the outgoing events? Yeah, it's okay. What is the problem? I don't know why it detects that the outgoing properties are not used. I don't know. So let's wait until this application is deployed. This is one of the new applications that we have configured. So well, it would be a new service on the OpenShift, and we will need also to basically add a Kafka client to the shopping cart service and to the order service in order to send events. But it is possible to, because by now the other 4 services that we have already deployed are not integrated with Kafka. And the problem is that if the, well, we cannot expect to receive any event from there because we have not coded the events or the integration with the Kafka cluster. So we have a payments application which is failing. Check what is happening. Something is wrong. What is wrong? Okay. First of all, is the Kafka extension added? Okay, so we have the Kafka extension added. Do we have all the properties properly configured? Maybe I did something wrong with the properties. Let's check. Okay. So I'm going to overwrite this with the my notes, which is basically the same. Okay, this is correct. Yeah, well, this should be the same. What is failing? Oh yeah, it was on naming of the property. So I had something wrong in the property name. So we need to rebuild because we need to have these properties again being rebuilt. And while this is being executed, we can maybe we're going to add, while the payment service is being executed, we're going to include the Kafka integration in the shopping cart service. Something very similar that we just did. So we need to add the same properties. I'm going to paste it here that we have added into the some imports are commented. Shouldn't be. Okay, so I am adding a producer the same way that I added the producer to the payment service. Okay, so we have a serializer, a topic, and a boosted server. And then we need to basically go to the payment service and copy the init method here. It's the same. Okay. Okay, so names are different. Orders, topic, value, serializer. Okay, so this is finished. Is this running already? Okay. Maybe we need to wait until a new pod starts. Okay, while this is working on its own, trying to redeploy the application, we are going to add the extension to the shopping cart service. Which is the extensions equals messaging Kafka, and then click enter. So I'm just adding the Kafka dependencies to the shopping cart service. Okay, that's it. Okay, something is failing. Check. Why is this happening with the payment service? I'm going to delete the payment service. Okay. Payment service deleted. Then we can go back to the shopping cart service. So what is happening in the payment service? So let's double check all the changes that we did first. The things that we need to have is the extension. We already checked that. The properties, we already checked that. What am I missing? What am I missing? What am I missing? Going to deploy it again. So maybe by seeing the arrow, we can see something something in the error because I don't know what is failing. So okay. I am thinking, I don't know what could have failed. Maybe the init method is not working properly. Try again. Okay, so basically what is happening is that the payment service is not able to start, although we have configured the producer and the consumer properly. But there is something that I am missing in the configuration that I cannot find right now. But at least we are not trying to use it. So either the Kafka cluster is not working, or there could be something wrong with the configuration I just did. Okay, let's see. Trying to get the logs on the command line just to see. Okay. Okay. Yeah. Try again. So the name of the property was not correct. So first of all, let's wait. But this init method that I had included into the shopping cart, it should be commented. So since we have already found the service, the error in the payment service, I am going to continue with the shopping cart. So the shopping cart is going to have a producer configured to the orders topic. Yeah, we have just configured the producer, and we have already added the Quarkus extension. We have already added the producer configuration. We need to include the, the event that we are going to send, or the order. So we have the method already coded. So this is going to be something similar to what we have on the payment service. So we are going to get the shopping cart from the shopping cart service. We are going to get the total. What is the problem? Can I get the value of this string? Okay, what is the problem now? That's okay. Okay, so we are going to send a total for the order, and we are going to create as well a record to be sent that is going to be of type string. So we are going to create a record. And one thing to consider is that in this particular record, the difference is that the object that we are dealing with is not a string anymore. It is an object. So we will need to basically serialize the object. So what we are going to do is that the topic is going to be the orders topic. It should be, yeah. Yeah. Partition key value header. So yeah, we are not going to really specify any of that. Not really nothing necessary for us, but what is necessary is to serialize the order object and also to include a header that basically we are going to add the content type header to be of type application case. Let's see if, okay, seems, what is the problem? What? Yeah. So yeah, the difference is that we need to send an object, so we need to build the string, and that now what we need to do is to use the producer to send the record that we just built. And maybe we have a log, yeah. So we can write the log that we have order sent. Okay, so sorry that I'm being a little bit fast, but we're running out of time. I wanted to show at least the Kafka working. So now the payment service is running, which is great. The card service is prepared to send an order, but we have configured a Kafka producer, not a consumer. So in the checkout method, we are going to uncomment this. And the moment the card shopping service sends an order, it is going to basically send the order to the Kafka topic that we have configured, but the card service itself is going to receive the event through HTTP. Now, the configuration of the application properties, we need to include the messaging properties. Something going to include it already. Something similar, exactly the same that we included in the payment service. And now we need to deploy application. At the moment the application is deployed, we can continue with the order service. In the order service, what we are going to do is that we are going to consume the orders topic, and we are going to basically update the status of the record in the database. So we will need to configure an incoming listener for both these topics, and we will need to deploy the order service. So it's not really everything that we are doing right now with Kafka. It's basically the same that we have already done, either configuring a consumer or a producer for a consumer. And yeah, that is basically all that we need with Kafka. We are configuring a set of incomers and producers. So, okay, it is deployed. We can go to the order service now. And the first thing that we need to do, as always, is, since we are working with the Quarkus framework, we need to add extension in order to have the dependency included in the class path. So we can use the the Kafka libraries. So now I am going to include a Java class that is going to be called Kafka orders.java. And I am going to copy the content and I'm going to describe the content to you. So this is nothing different of whatever we have already done through the workshop. So we have a class here that has an incoming on the orders topic, an incoming on the payments topics as well. And what it's going to do is that basically order has a status. When you create an order, you have a status of processing or in progress. And the moment you receive a notification on the payments topic, it is going to get the status of the payment and update the order with its status. So basically, in the payment service, if the field status is either completed or failed, in which we're going to send a topic to the payments topic, we're going to send a payment event, either successful or failed. It will be received by this particular topic. It will get the order associated with that particular payment, and it will update the status based on the status that the payment service has included. I know that is a little bit complicated to follow, but the shopping cart service sends an event to the order service, which is this order service here. And then we have a payment service over there that is going to update the order status. So what we need to do now is include the messaging properties, which I think is not this service, order service. Okay, I'm going to include the messaging topics. Okay, so now what we need to do is to build the order service. So I'm going to do a main include package. So the moment we do the checkout of a shopping cart, it will set an event. The event will be consumed by the order service, will be consumed by the payment service. And then when the payment service processes the payment, it will send a payments event to the topic that will be consumed by the order service, and the topic will be updated. That is basically how the flow is designed. And when this payment is processed, we can try to do an end-to-end testing of all the end-to-end functionality. So as we can see, we have lost the labels, but that is okay. Okay, it is finishing of building the application. Next. Okay, so now we need to wait until the order service is redeployed. Let's check. It is still on container creating. Seems to be completed already. Okay. So what I am going to do is I'm going to try to do a test. So I'm going to add this cert to my cart, and I'm going to do a checkout, and I'm going to write random numbers. I don't know. 1, 2, 3, 0, 1, 1, 3, and we are going to zip it to, I don't know, a bit. Okay, so we have an order that is being processed, and ideally in 5 seconds we will see the order being completed. So the end-to-end flow is working. The end-to-end flow is a little bit complicated because we are sending an order to the order service that when it's created is created on processing, And yeah, and then the payment service is the one that is responsible for for updating the status of the payment, either successful or completed. So what I'm going to do now, I am going to do it a little bit faster. We are going to use the Knative event integration with Kafka in order to be able to scale down the services to zero if the service is not being used. So if it doesn't have any messages going or events going through the topic, which allows us to we have a high performance situation requirement in which we have a very rapid peak of requests, but at the same time we have some times of the day in which we have a very low number of requests. Then we don't want the application running on that situations. So what we want to have is the application stop when we are not receiving any traffic. At the moment we receive any traffic or any event, start processing and start. We want the application to be started as fast as possible and try to save the resources when we are not really needing the resources. We are going to do that at the payment service. So I am going to delete the payment service resources, the build configuration, and the image string. I'm going to delete also the deployment config. So now what we need to do is in the payment service, on the payment resource, we are receiving messages from the orders topic, which is at the end of the day, which is forwarding or generating the payment processing, and its results is forwarded to the payment topic. What I'm going to do is I am going to delete this method. So there is no integration of incoming Kafka. This is something important. We need to delete some configuration. We need to delete the incoming configuration from for Kafka because we are not going to use it. And we are not going to build a, well, let's say a normal, we're going to build a container native application. So we are going to change some properties here. What properties are we going to change? So for example, the deployment target is not OpenShift, it's Knative. So I just paste the properties here. Okay. So we have the namespace, we have the image registry, we have everything. And we don't have any incoming Kafka configuration. And we have not changed how the orders event is sent. We have not changed how the, let's say, the order event is sent to the payment service. Now, in order to, first of all, make the compilation or build the application in a native way, we need to specify the Quarkus that this has to use the native profile in order to build a container native application that is going to be able to use the Knative functionalities. So basically, or in other terms, we're going to use GraalVM instead of using the JVM, which is having more thought in the containers world, and it is also useful for running application written in JavaScript, in Python, Java, Scala, all the languages that run on a JVM run on the GraalVM. And the difference basically is that in terms of compilation and optimal packaging, it is much better than the traditional Java virtual machine. So let's wait a moment until the application is deployed. And I only want to show you 2 more things, and then we can close the workshop. Because so we can we're going to wait until the application is built. It takes some time to compile the application, but it is going well. So we don't have any payment application here. We need to wait a little bit, but I think it's worth it because it's when we can see some capabilities of the serverless containers in OpenShift or native containerized applications, in which this kind of functionality is ready. While to do it with some traditional frameworks and tools is a little bit more difficult. So right now, I think it is building the image, the OpenShift image. Okay, so where is the payment service? There you go. Now, if we wait 30 seconds, the payment service will scale down to 0. While it scales down, I am going to add one thing. I have removed the Kafka incoming from the service. In order to connect the Kafka topic to the service, or in order to send the event, we need to add one thing to the namespace, which is an object of type Kafka source, which is a Knative object in OpenShift. Basically, this object is configured to be connected to the Kafka cluster, and I am specifying that whatever goes to the orders topic goes to the sink of the defined by this particular service, which is the payment service. Perfectly create. Go back to topology. Payment service right now is being scaled down because we have not sent anything to the payment service. And we can see the Kafka source here. So mind that basically the Kafka source, if we click here, it really has a sink which has a URI configured, which is the payment service URI, which is basically what is going to call is this post method. Because this post method is exposed on the root of the application, and at the same time, it was the very same method that the orders topic was, or the orders topic consumer was executed. So I'm going to buy another theme. So mind that payment service is down. There is nothing here, and there is no integration with any incoming Kafka source. We have done the scale down to 0 and the integration with the Kafka source dynamically with the Knative framework. So yeah, I have one item in my cart. I'm going to do the checkout again. I'm going to say that it's me. And I'm going to put the same values. Well, I'm going to change something just to be able to differentiate. So I'm going to send it to Barcelona now. And then we can see that there is nothing processing, and now the payment service is started because there is an event that has been received from the orders topic. The payment service is started already. It will be processing the topic. So in 5 seconds, we will see that payment is completed. So it has taken totally 10 seconds, out of which 5 are our thread.sleep. So basically in 5 seconds, the application is able to start, consume, and process the message. And the other 5 seconds is just in terms of simulate the processing of the message. Mind that this kind of architecture and this kind of frameworks could be a little bit harder for a developer to use and to learn because there are a lot of differences. But mind also that at the end of the day is Java language what we have used, which is a very well-known language among the developer community. And we also have a lot of libraries, a lot of extensions that we can use in the Quarkus framework. So I think that would be all for today. I'm going to stop sharing my screen. So thank you all for attending.